Hey everyone, today we're going to be solving the next four questions as another practice drill for Unit 2. So let's get started. Question 1, very simple question. They said we need to differentiate and simplify. Now as you can see over here, like these derivatives over here, they're going to be using chain rule and quotient rule for them to be solved. So in part A, we got x to the power of 2 minus 9, all of it to the power of 4. So according to chain rule, f prime of x, the 4 is going to drop down, and then you're going to get x to the power of 2 minus 9, all of it to the power of 3, and then you multiply it by the derivative of whatever is inside over here, which is going to be 2x. All right. Now, if you want to simplify even further, the x squared minus 9 is basically x minus 3, x plus 3. This comes from the fact that a to the power of 2 minus b to the power of 2 is equal to a minus b, a plus b. So the fully factorized form, you can say 4 multiplied by 2x multiplied by x minus 3 to the power of 3, x plus 3 to the power of 3. Because over here x squared minus 9 was to the power of 3. Otherwise, you can leave it as it is over here. This is also considered to be a simplified form. Now, for part B, you got 2x multiplied by sine 2x. Now, this is a problem for product rule, because over here you have two functions that are multiplying each other, which are 2x and sine 2x. So f prime of x is going to be of the form u prime v plus uv prime. So u prime in this case is going to be 2. V is going to be sine 2x plus u, which is going to be 2x, and v prime, it is going to be the derivative of sine 2x. According to chain rule, the derivative of sine 2x is going to be 2 cosine 2x. Now, 2 multiplied by sine 2x is 2 sine 2x, and then 2 multiplied by this 2 over here is going to be 4x cosine 2x. This is an optional step over here. If you want to factorize it even more, you can take 2 as a common factor, sine 2x plus 2x cosine 2x. Okay, so this part over here is going to be optional. Usually the reason why we factorize sometimes is if you encounter a question where they tell you like find f prime of 3 or find f prime of 4 or whatever, it is better for you to use the factorized form because it means less work on a calculator. So yeah. Part C. We got cosine x over 2x. This is going to be quotient rule because you have a function which is a quotient of two different functions. So the rule for quotient rule is u prime v minus uv prime over v to the power of 2. So now f prime of x, u prime is going to be negative sine x, v is going to be 2x minus u cosine x, and v prime, it is going to be only 2 over 2x, all of it to the power of 2. Expanding, you're going to get minus 2x sine x minus 2 cosine x over 2x to the power of 2. You never would want to expand the denominator because the denominator is just v to the power of 2. There is no significance behind it. So just keep it the same way. Now, if you take minus 2 as a common factor, this is also over here optional. If you take minus 2 as a common factor, you will be ending up with x sine x plus plus cosine x. if you want to make sure that your factorization is correct, try to expand it again and see if you're going to get the same exact thing as the ones over here. For example, minus 2 multiplied by x sine x is going to be minus 2x sine x. So the first term is correct. And then minus 2 multiplied by cosine x is going to be minus 2 cosine x. So this is basically how you know that your factorization is correct. This is it for question 1. Now, question 2, very simple question. They told me to find f prime of 2, given that f of x is x plus 1 over 2x minus 1, x is different from half. So over here, obviously, we're going to use quotient rule because the function is made up of a quotient function. So f prime of x, u prime, it is going to be 1. V, it's going to be 2x minus 1 minus u. V prime, it is going to be 2. And you need to divide all of that by v squared. Now notice over here that they wanted me to find f prime of 2. So this is the part where you actually have to simplify to the best that you can. So now, 1 times 2x minus 1 is going to remain 2x minus 1. The minus over here is going to go inside all of these terms over here, okay? So what you can do is put the minus over here and multiply the 2 inside first. So open brackets, 2 times x is going to be 2x, and 2 times 1 is going to be positive 1 over 2x minus 1 to the power of 2. Now, the minus is going to distribute inside, so you're going to get 2x minus 1 minus 2x minus 1 over 2x minus 1 to the power of 2. Now, 2x and negative 2x are going to go away. Negative 1 is going to be negative 2 over 2x minus 1 to the power of 2. Finally, f prime of 2, you just replace x with 2. So negative 2. 2 multiplied by 2 minus 1 to the power of 2. You're going to get negative 2. 2 multiplied by 2 is 4. Minus 1 is going to be 3. To the power of 2, it is going to be 9. So this is it for question number 2. Moving on, we have question number 3 over here. Let f of x equals x ln x minus 3x. X is bigger than 0. Find the coordinates of the critical point. Notice over here that they said the word coordinates. That means they want us to find x and y of that point, of the critical point. And when they say critical point, it means that f prime of x should be set equal to 0. So let's start first of all by finding f prime of x. Now f prime of x is going to be the derivative of f, obviously. And as you can see over here, we got x ln x. But x ln x by itself is a product rule function because it's made up of two functions multiplying each other. So the derivative is going to be u prime, which is 1, v plus u, v prime, the derivative of ln x is 1 over x, and then minus the other term over here, which is the minus 3x. The derivative of minus 3x is going to be minus 3. So now, let's fix its shape. Now, x and x are going to remove each other, so it's going to be ln x plus 1 over here, the 1, minus 3, which is going to be ln x minus 2. Now, to find the critical points, you have to assign f prime of x is equal to 0. So, ln x minus 2 is equal to 0. That means that ln x is equal to 2. So how do we find x in this case? If you don't remember, in order for me to remove the ln from next to the x, I have to raise everything under the power of e. So now e and ln will cross each other, and then x will remain, and e will be to the power of 2. Now, since x is equal to e to the power of 2, I still need to find the y. So I replace e to the power of 2 with the x's in the original function. So you basically need to find f of e to the power of 2. So it is going to be e to the power of 2 ln e to the power of 2 minus 3e to the power of 2. Now ln e to the power of 2, it is going to be 2. So it's going to be 2e to the power of 2 minus 3e to the power of 2. And 2 minus 3 is going to be minus 1. So minus e to the power of 2. So the critical point, it is going to be e to the power of 2 minus e to the power of 2. And that is it for question number 3. Now the final question for this video, question number 4. They said, let f of x be equal to x squared minus 2x plus 1 multiplied by sine x. Determine the equation of the tangent when the function is crossing the y-axis. Now, first things first, since they said they wanted the equation of the tangent, we need to understand over here that we have to use the formula y minus y of a equals y prime of a x minus a. But usually whenever they ask us this question, they would tell us explicitly that x is equal to a number. Like for example, determine the equation of the tangent when x is equal to 1 or when x is equal to 2 or something. But instead, over here, they told us to find the equation of the tangent when the function is crossing the y-axis. So there's a trick over here. If you imagine with me a function, a random function, and it's crossing the y-axis, the special thing about this point over here is that the x value of this point is 0. So it's as if they're telling me that I have to find the equation of this tangent when the function is crossing the y-axis. That means they're telling me that x is equal to 0. So this is the trick over here. So now instead of a, we replace it with 0. So we need to find y of 0, y prime of 0, x minus 0. So first things first, y of 0, which is going to be essentially f of 0, we replace x with 0 over here, and we're going to end up with 0. Because sine 0 is 0, and 0 multiplied by anything is 0. Now, y prime of 0, we need to find y prime of x, which is f prime of x. So we need to find the derivative of the top function. Now the top function is of the form of a product function, u multiplied by v. So now you have to apply product rule to find y prime of x. So y prime of x, u prime, it is going to be 2x minus 2. V is sine x plus u minus 2x plus 1. And v prime, it is going to be cosine x. So this is my derivative over here. And now I have to find y prime of 0. So instead of the x's in the derivative function, you replace every single x with 0. Now, since you're going to replace 0 instead of like sine x over here, sine 0 is going to be 0. So all of this part is going to result with 0. Now the second part, 0, 0, and then 1, cosine 0 is going to be 1, right? So you're going to be ending up with plus 0 minus 0 plus 1. And cosine 0 is 1. So 1 times 1, it is going to be 1. So now my y prime of 0 is going to be 1. So now if you plug this in your formula, y prime of 0 is equal to 1, and y of 0 is equal to 0, this is what we're going to get. We're going to get y minus y of 0 is 0 equals y prime of 0 is 1, and then I have x minus 0. So y is going to be equal to x because 1 times x is literally x. So this is going to be my tangent equation. So this is it for this video. Make sure you stick around because there's going to be one final practice drill for Unit 2 before we wrap it up. And thank you very much.